Okay, when you look at a rock, what do you really see? Something solid? Permanent? Maybe? Kind of boring? Well, today we're going to totally flip that idea on its head because every single rock is on an absolutely incredible, endless journey. So let me just ask you this. Do rocks have a secret life? It sounds like a pretty wild question, right? But the answer is a huge yes. They are constantly changing, breaking down, and being remade in a process that literally shapes our entire planet. And that's the secret. They are all on an endless journey. This is the whole idea behind what we call the rock cycle. It's not some story with a neat beginning or end. Nope. It's a continuous loop of transformation that's been going on for billions of years. So, to really understand this journey, first we need to meet the main characters. I like to think of them as three distinct rock families, and each one has its own unique origin story. First up, we've got igneous rock. That name comes from the Latin word for fire, and that's your perfect clue right there. These are literally fire rocks, born from the insane heat deep inside the earth. When molten rock, magma or lava, cools down and gets solid, boom, you get igneous rocks like that dark basalt you see in lava flows, or the speckled granite that might be on your kitchen countertop. Next, there's the sedimentary family. Now, these rocks are basically Earth's history books. They're made from all these tiny pieces, sediment, like sand, shells, little pebbles, that get broken off other rocks, carried away by wind or water, and then just dropped in layers. Over millions and millions of years, the weight from all the layers above just squishes them together until they become solid rock, like sandstone or limestone. And our third family is metamorphic rock. The word metamorphic just means to change form, and that is exactly what's going on here. You can take any rock, igneous, sedimentary, even another metamorphic one, and if you subject it to incredible heat and pressure deep inside the earth, it will transform. It doesn't melt, but its whole structure rearranges, turning something like limestone into beautiful marble or shale into slate. So the bottom line is that each family has a totally different origin. Igneous? That comes from melting and cooling. Sedimentary is all about being built from broken pieces that get cemented together. And metamorphic, well, that one's all about being changed by heat and pressure. Three families, three very different stories. Okay, so we've met the families. Now let's get to the action. What are the forces that actually drive these incredible transformations? These are the adventures, the challenges that push a rock from one form into another. Let's just trace one specific path. For example, becoming a sedimentary rock. It all starts with weathering and erosion. That's just wind and rain breaking down a mountain, bit by tiny bit. Then comes deposition, which is when those bits get dropped off somewhere new, like the bottom of a river. And finally, over huge amounts of time, compaction and cementation basically glue all those pieces together to form a brand new rock. But weathering isn't the only game in town. Deep inside the earth, you've got the real heavy hitters, intense heat and crushing pressure. These two are like the sculptors that create metamorphic rocks. And if the heat gets turned up high enough, any rock can just completely melt, turning right back into magma, ready to kick off the whole cycle all over again as a new igneous rock. Okay, now this is probably the most important thing to get from this entire explainer. We call it a cycle, but it's not some simple, predictable circle. The rock cycle is a super flexible and often unpredictable journey with tons of possible paths. For example, a really common path is for an igneous rock, say a big chunk of granite in a mountain, to get worn down by rain and wind. Those tiny granite bits can then get washed into a river and eventually form a sedimentary rock. Super straightforward transformation, right? But what if a metamorphic rock gets pushed even deeper into the earth? It's not going to become a sedimentary rock. Instead, it can get so incredibly hot that it just melts completely, turning back into magma. And when that magma cools, it forms a new igneous rock. See, it didn't follow that standard circle at all. This really gets to the core idea. The rock cycle is flexible and always changing. There's no beginning or end. A rock can be remelted, reweathered, or recooked countless times, and it can take a totally different path on its journey each time. So, why does any of this ancient, slow-moving journey matter to us? Well, because this cycle is responsible for creating the very ground beneath our feet and all the amazing landscapes we see every single day. I mean, just think about it. That immense pressure that creates metamorphic rocks, it also pushes up towering mountain ranges. The relentless power of erosion that creates sediment, that also carves out deep valleys and canyons. It breaks down rock to create the sand on our beaches and the fertile soil we absolutely need to grow our food. Everything is connected back to this cycle. And it is so important to remember the scale of this. We're not talking about days or even hundreds of years. We are talking about millions, sometimes hundreds of millions of years. It's a timescale that's almost impossible to really wrap your head around, just happening slowly and powerfully all around us. All right, let's put it all together. We've seen that a rock's journey is this continuous cycle, and it's driven by forces like weathering, heat, and pressure. These forces transform rocks between those three main families: igneous, sedimentary, and metamorphic, on a journey that has no single path and no real end. So with that in mind, let's see what you've learned. I'll leave you with this final thought to chew on. Which type of rock is most likely to form near a volcano? And why? Think about the forces we talked about, the families we met. The answer is hiding right there in the cycle. Thanks for joining me.